Hello everybody, how's it going? This is week 6 in our class, if you can believe that. That's going pretty fast if you ask me. So announcements, a bunch of, well, two things here, and that's a regular office hours announcement, but then our final exam. Now remember, the final exam is final based on the Zybook materials. So it's going to be an objective, multiple choice, that kind of stuff, test about the Zybook material. So we're going to do that when we finish with the Zybook material, which turns out to be in about 3 weeks. So we're moving along here pretty quickly, and we've got to get ready for that Zybook exam. Now, one thing you'll notice is that it's a take-home exam. Okay, so that's one thing. I'll post it on Friday the 10th. Well, guess what else starts on Friday, March 10th? That's your spring break. So if you're smart and if you have plans for spring break, what you want to do is to plan to just do that objective exam on Friday the 10th. As soon as it's available, then you've got the rest of your spring break all to yourself. You don't have to think about it. However, if schedule is tight for you, you've got until Tuesday the 14th to get it done. So you've got some flexibility in there, and that's what I'm going for, to try and make this as flexible as possible. It's going to be of the format where you once you start the exam, you get 2 hours to complete it, something like that. I can't remember the number off the top of my head. But so you can't start it on Friday the 10th and work on it until the 14th. So just pick your 2 hour slot or whatever it is, and I'll get more details to you as we get closer. Pick your slot, do it, be done with it, go out and have a great spring break. Woohoo! So group project, remember, we're coming up on that. As soon as we come back from spring break, that's when we start working on the Google's BigQuery and Data Looker. So at that point, you're going to have one assignment that is going to be kind of a, do this thing, do some e-commerce analytics kind of thing in BigQuery, and it's very well supported. And get you to give it a try and see how it works. That's my goal for the assignment. And then you'll have your project to work on. And the reason I do that is because I expect you to take a lot more ownership of the project than the silly little assignment that I give you. So anyhow, so that's coming up too. And let's see, start thinking about learning this. Spring break might be a good time to go through a couple of assignments or some of the online resources for Google or LinkedIn Learning or whatever. Well, I had a question about number of people in a group, and I was asked if 4 was okay, and I said, yeah. It's okay, it's up to you, but remember, as the groups get bigger, the scheduling gets harder. That's why I try and keep my groups smaller, but if you really must have 4 people in your group, fine. But 5, you'd never find the time to get together. But yeah, so get in touch with me. If you have any questions, I'm happy to help out. If you're behind on stuff, get in touch with me. I'm happy to help out, okay? I don't want anybody to do badly on any of those PAs or CAs or the Xylabs. Everybody should get hundreds on those. So, all of a sudden, this week's material is a lot harder than before. Before, it's been pretty straightforward stuff. But this week, we get into some really important concepts, between functions, joins across tables, subqueries, relational algebra, all that kind of stuff. And it all comes through in Xylab number 3, which is due on the 3rd, which is next week. So you're going to have to, set aside some time for this. Xylab 3 is going to be harder than the previous Xylabs. mostly because you're doing these joins, and the joins are kind of weird to work with. Once you get a feel for them, you know, they're not too bad, but you do have to leave some time around for them for you to work on those. So all of a sudden it's getting a lot harder, and that's okay. So functions. So we'll just go through those 4 different topics, and we'll just do what we can. I'm not going to read all these slides; it would take too long. I'm trying to keep these recordings a little bit shorter. But functions are just basic things. They're things like absolute value. Given a list given an argument, what's its absolute value? What's the square root of some number that you give it? So kind of like transforms that you're doing on numeric data. String data, we've got our own set of functions that we work with string data, or you're concatenating things. You're taking values from 2 different cells and sticking them together. You'll notice that these are by the row. So numerics are by the row. We give it one value and it gives back something else. The strings, we're going by the row. Within this row, we want to do a transform. We want to take everything from uppercase to lowercase. Figure out substrings within a string. If you've got first name, last name in one field, how do you find the first name? Well, you can do that. Then we have date and time functions. Why do we have date and time functions? Because it would be so darn hard otherwise. Date and time is something we work with all the time in databases, and we need to get it right. So things like date diff. How long has it been between this date, between when somebody first signed up for our service and when they last paid, or something along those lines. Those are really good ones. Then we get into these aggregate functions. Now, aggregate functions are different. You'll notice that the numeric string and date and time, that was per row. Aggregate functions are more things like count the number of entries that we have in this whole column, or find the minimum value in this column. So aggregate functions are much more likely to be by the column than the numeric string and date and time functions, which are by the row. The next thing that we have are group bys. So a group by, you take a select clause that can contain only columns that appear in the group by clause. Let me bring that up in the Xi book, because that's kind of hard to explain. Blah blah blah. Okay, so let me go back one here. And week 6. Let's see. Aggregate functions. Sorry, I had a relaunch of Chrome to go through, and all right, so here's my Xi book, and aggregate functions. These are the by the column thing. So if you're looking at the average salary, so here we've got employees and we've got salaries and stuff, and so we want to find the average of these. So if you'll notice, those aggregate functions work vertically. And let's see, then we've got this little thing here. The Xi book does a great job of telling you the main thing to remember. So aggregate functions appear in a select clause and process all rows that satisfy the where clause condition. So you've got the select and the where to deal with. Now in here, Come on, little feller. So our select says count, count all the values from employee where bonus is greater than 500. So the select part, let's see, process all the rows that satisfy the where clause condition. So here's our where clause condition, and the select clause, in this case count, is going to count all those values that satisfy that condition. Now our next one, select min salary from employee, that one's just looking at the salary column because we don't have a where condition in there. We could add one, but we don't have one. But anyhow, so that's an important part about the aggregate functions in a select clause. And you know, these are good ones. Counts and mins and maxes and sums and averages. Those are things we do all the time. And these exercises, by the way, are really good. Now, group by, here's another one that is really useful. So pay attention to the group bys. I guarantee it's going to be on the final exam. And you're going to want to do group bys as part of your project and as part of the big query assignment 1. So, you know, you got to learn it. So your group by, the thing to remember is, once again, right here. So the group by clause appears between the where clause, if any, and the order by clause. Aside from the aggregate function, the select clause may contain only columns. The select clause can contain only columns that appear in the group by clause. That's an important thing to remember. So what they're saying is we've got the select statement up in here. Select country code. Come on, little fella. And but our group by has to have a value. I don't know why it's going so slow. Our group by has to have the same value in the select statement. So our select statement's got two different columns that we're working with: country code and the sum, an aggregate function of the population. So what are we going to get here? We're going to get we've got country code, ZMB, and ZWE, and what we're doing is we're summing the populations of these different cities, and so we're grouping them by country code, ZMB versus ZWE, and then we're showing the sum of the population value. So we're doing our summing on this side over here. So that key thing is this last little bit here, where you've got to have the, let's see, select clause may contain only columns that appear in the group by clause. You can't select something or you can't group by something that you haven't selected. That's really what it's like. And so in a lot of cases, these are going to be like aggregate or subqueries that we look at in just a couple of minutes. So here's, practice with your subquery, your aggregate functions and group bys. And order bys also. So order by is basically how do you index the things that come out in your group by. And as you can imagine, that's a popular thing to do. Select year max price from auto, group by year and type, order by, I think it would be year. Yeah, because we don't have this first one is wrong. It's got to be because we got to have the group by has to be in our select statement, and it's not there. So work your way through those. Make sure that you understand that side of things. Let's see. So having is another way to do it's kind of like a subquery, or querying after we do our previous query. But anyhow, all important things to pay attention to. These are really good too. You should get used to this stuff. Now, I can guarantee that there's going to be things like create table statements. I don't know why I can't select in there. As part of your final exam and everything else. So, you know, just be ready to work with that stuff. Let's see. Here's that one. And so we're finally getting into some interesting queries. That's what I like about this stuff. Now, what do we do with null values? So, where does that come up? Well, you know, if you're looking in this table here, if you're looking for the average bonus, well, what does null mean? Null does not mean 0. Null means something besides 0. It means nothing. And so how do you average in nothing with 1,000 and 3,000? So there has to be something that's decided what to do with the null value. And in this case, we kind of ignore null values. So we ignore those null values. So we can do an average bonus on this query because, you know, we need to know what's the average bonus. But if you think of it as what's the average bonus of those people who received a bonus, that's kind of what, you know, how we work with null values in this thing. We just exclude them and say, you know, they're not part of our query because null is not 0, and we can't, you know, do anything with that if you know it doesn't have any value. So let's see. There's that one. Make sure you work through all these, and that's a good CA. Now, join queries. This is another one that we've got. Let me go back to here. So that's my functions. Join. So a join is a select statement that combines data from two tables, known as the left table and the right table. How do you know which is the left table and which is the right table? Well, let's see. So let's see. The left table is the one that comes up first in the from statement. So let's see. Left table, right table, and same result. Usually a join compares a foreign key of one table to the primary key of another. So we're going to have a primary key in one table, and that's going to be included as a foreign key in another table. When we do that, when we have primary key in one that's carried as a foreign key in another, then we just say, link those two together. Make it so that we can connect those two together. Let's go back to here again. So join queries. Usually, okay, there's that one. And be sure that you work through all these. Let's see. So if we look at this guy and say, given this query here, which is the left table and which is the right table, look at the from statement. The first one is the left table. So employee is the left table in this one. The right table is department. And it makes sense because it comes first. It's on the left in English. Then, you know, department comes second. It's on the right. So that makes sense. But it's in that from statement that we find out which table is left and right. So which columns can be compared in a join? Only columns with comparable data types. So it doesn't have to be primary key and foreign key, as long as the data types are comparable. Sometimes what that does, it allows us, you know, if we've got a string of 3 tables that are linked together, we can jump that middle table to link the third table to the first table directly based on 2 fields that have the same data type. That's a useful thing to do. In a join, what are the first and second tables in the from clause called? There we go. So the left and right tables, respectively. That's what the order of when we're calling the tables in the from clause determines which one's left, which one's right. As we get into inner joins, outer joins, self joins, all those kind of other kinds of joins, that's where this is going to matter. Now, what's missing from the join statement here? Let's see, select employee name and salary. Now, this is from up here. So we want employee name and salary. Well, why would we do a join? All we're looking at is the one table, the employee table. We don't have any columns from the department table in the results to our query here. So the problem that this last one has, what's missing from the join statement, is that no columns from department appear in the select clause. I hope I got that right. I just said it wrong. There we go. That's the one. A column from employees not compared to a column from department. No columns from department. I got it backwards, didn't I? Anyhow. So you know, why do a join if you're not going to ask for any columns from the both tables? Now, this one is one that's gonna, you know, mess you up a little bit, okay? Because right away, a lot of the labs, the Xilabs and everything, and a lot of the BigQuery queries and stuff use these aliases all the time. So you know, what does department.name as group mean? What is that? Well, it's department.name. So in here, and then what do we want to call it? Well, instead of calling it department.name, we just want to call it group. Okay, fine. But that's how you do it, using that as clause. It turns it into an alias. And where manager equals ID, that's our link. So that's our join right in there. And let's see, okay, so we got that one. Now, what we're going to do most of the time are inner joins. So inner joins are the ones that are the most useful because it selects only the matching left and right table rows. If you know, if we don't have a row in one table that matches the other table, what do we want to show a row that doesn't have any data in it or doesn't have any match in it? That's why most of the joins we're going to do are inner joins. And inner joins, a lot of times we don't say inner joins. We do something like, let's see, where we've got this where statement, where manager equals ID. That doesn't say inner or outer join, but in fact, that's an inner join. So a lot of times we're not going to say the type of join, but most of the time when that happens, it's going to be an inner join. And let's see, here we got full joins, inner join, full join. You should know those two, and you just have to work with them, and you know, it'll become apparent. Then we've got our left and right joins. Well, you know, left and right joins you can kind of manipulate by your from clause. You can determine which table is on the left and which is on the right based on which one comes first in your from clause. So, or you can use a left or a right join. So, you know, it's up to you how you do that. And let's see. And so, you know, left, right, inner, outer, all that stuff, that just means that you're looking for which values do you want to include? Which rows do you want to include? Ones that have no value that matches, or only the ones that have values that match? Then we've got, you know, the other kind of union keywords and stuff. There's a bunch of different kinds of joins, but we're really not going to do much with those. But then you've got this join coding exercise, which is really good, and you can work on that one. And then here's our CA, and let's see, equijoins, self joins, and cross joins. Yeah, they're out there. We're not going to do a whole lot with them, but you should work your way through this just to figure it out. I'm trying to go fast here. And to get to subqueries, let me go back to here, and these are my joins. Here are my subqueries. So what are subqueries? We're going to use a lot of subqueries. So a subquery is kind of like a nested query where we've got two queries within one query. And what we want to do is we want to take the results from one query and use those as the input to a second query. Well, subquery is typically used in the select statement's where clause to return data to the outer query and restrict the selected results. Here's the thing. The subquery is placed inside the parentheses and is run first. So what that means is that the sub part of the subquery is going to be the second part of the query. So here is our subquery in the parentheses down here. So this part is going to run first. The output from this part is then going to be taken to this part, to the other part of the subquery. So what comes back from the subquery? Well, just this value 5.3 in this case. In this query over here, first we run select code from country where continent equals Europe. Okay, that's our subquery. What does that mean? Well, continent equals Europe is here, so that's Albania and Andorra, which has codes, select code, ALB and AND. So that's going to come back to this query here and select country code language from country language where country code in, here's what it's looking for, where country code in is ALB and AND, and what we want to get is we want to get the country code and ALB and AND, and then language, which is let's see, so country language. So we're combining these two tables in here. But what runs first? This is the part that students seem to have the most trouble with. The part that runs first is the subquery, the part that's in the parentheses. Okay, then the results from that subquery go back as a result table, because remember, that's what happens anytime you've got a select statement, and here we've got select code from country where continent equals Europe. That's going to return a result table. Then that result table is going to be that we're going to use in our where statement, where country code in the result table. In this case, the result table happens to have ALB and AND in it. Okay, so that's how we work with subqueries, and they're really useful, and we're going to do lots of subqueries, and so be sure to work your way through this. I'm going way over what I wanted to do. Correlated subqueries, yeah, those exist. We're not going to do a whole lot with them, and where exists, if you're looking for something that comes back from one table as the subquery, and we got all that. And what was this last part? Oh, flattening subqueries. Okay, well, whatever. And then we've got our complex queries. Now, the thing about complex queries, oops, there it is. So how do you do complex queries? What does that even mean? Well, in this case, what you're thinking about is really kind of a work process, a workflow that you're going to use when you start getting into queries that are kind of complicated. How do you approach this? Well, first thing, you want to be methodical in how you approach those complex queries. The first thing to look at is an ER diagram or some sort of table diagram to understand what fields are in the tables and how do they relate to each other. What are the relationships between the tables? Where's the primary keys? What's the foreign keys? What's the left table? What's the right table? Which table is driving what? Are there like subtables? How do the tables relate to each other? Then identify the tables that containing the necessary data to answer the question. Sometimes you can skip tables. So if you've got 5 tables that could potentially be linked together, do you have to link all of them together? Are the columns that you're looking for spread out across all 5 tables or not? Maybe they're over in one side of the ER diagram that you're looking at. Maybe they're in the other side, in which case you can cut down on the number of joins that you have and make your query much more efficient and much easier to troubleshoot when it doesn't run right the first time, because nothing works right the first time. Determine which columns should appear in the result table. What do you need to know? Write a query that joins the tables using the table's primary and foreign keys. Show lots of tables, select lots of columns, and to make sure that your joins work right. And then break the problem into several simple queries, writing one part of the query at a time. Can you do a join across first 2 tables? Even if you need to get to 5 tables eventually, can you join those first 2 together? Does the join part work? If the join part works, then then you can add another table and you can say, I've got a good feel for how this is going to work together. I kind of know where I'm headed, and then you can make it more complex step by step. That way, when something happens where it breaks, you'll know, oh, well, it used to work. Now I added this part and it doesn't work. What's the broken part? Well, it's that part that you just used. If you try and, go for broke, string them all together at once, and it doesn't work, you don't know where to start. Start simple. Start with 2 tables, join them together, try your where statements in there, try your subqueries, try all that stuff, but start with 2, add a third, add a fourth, add a fifth. Once you get all those joins together, then you got the joins working. Now you can start thinking about how do we add more complexity into this to, eliminate columns that we don't need, to add counts or whatever aggregate functions that we need. How do we build this out slowly but surely? And don't call me Shirley. Ha 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 ha. And that's all I've got for today. So take care, everybody. Have a good week, and spring break is coming. Yahoo!